Hi students, all of you welcome. I am Suneel Bandaru, plus educator in Unacademy. Students, actually SSC JE or UPPCL JE or RVUNL JE classes are running in the YouTube channel Unacademy JE and AE exams. Okay, due to some technical issue, I am taking the classes in this channel. Okay, if you want my previous sessions, you can watch in Unacademy JE and AE exams YouTube channel. Okay, and here we have already completed 10 sessions in DC machine series. DC machines topic wise MCQ series. I have already completed 10 sessions in the channel of Unacademy JE and AE exams. Okay, if you want previous sessions, you can watch in this YouTube channel. Okay, now I am going to view the session that is 11th session. Okay, already that means we have already completed the topics in generator. So now onwards we are going to discuss the MCQs belongs to DC motors. Okay, let us start the session. This is the first question. The force experienced by current carrying conductor lying parallel to the magnetic field is dash. The force experienced by current carrying conductor lying parallel to the magnetic field is dash. Come on, very easy question. Here we know very well when the force experienced by a current carrying conductor. Here if we have magnetic field, let us take the flux density is B, and if you consider a conductor that is also having current, the length of the conductor let us take L. Okay, then according to Lorentz force equation, whenever we place a current carrying conductor in a magnetic field, according to Lorentz force equation, that conductor will get the motion, the conductor will get the force. Due to that force it will be rotated. This is the motoring principle. I think all of you know this one. So according to this motoring principle, Lorentz force equation, force is equal to, this force depends on this flux density and current carrying and also length and sine angle between these two. Sine angle between the current carrying conductor and also magnetic field, that is sine theta. It is the force equation. Okay, here they have given the current carrying conductor lying parallel. Lying parallel means if the conductor is lying like this. Then what about the theta? Here conductor is in the same direction. Conductor is like this and magnetic field also like this. So both are like parallel. That means what about the theta? Angle is 0. If the angle is 0, what about the sine theta? Sine 0 is 0 na? So 0. So if this value is going to be 0, the force also will become 0. Okay, so whenever a current carrying conductor lying parallel to this magnetic field, the force will become 0. If you place like perpendicular, for example, it is a magnetic field direction and this is your conductor. L length of the conductor, it is having the current. Now what is the angle? 90 degrees. If we have the 90 degrees angle, then what you will get? F is equal to BIL. Sin 90 is equal to 1. So you are getting maximum. Maximum force is equal to BIL. Okay. So here parallel they have given. So we can say that is 0. In case of perpendicular, that is BIL, this option C. Okay, if they have not mentioned anything, the force is nothing but BIL sin theta in that case. Okay, coming to the next question. The current flowing in the conductors of DC motor is dash. The current flowing in the conductors of DC machine is dash. In the previous classes, I have given that either it is a DC generator or DC motor. DC generator or DC motor. In armature, we have AC current only. Okay, if it is a DC generator or motor, anyone, if it is considered as armature. Okay, in this armature, we have the set of conductors. In armature, we have always AC only. Okay, in case of it is a motor, we are giving DC supply now. We are giving DC supply. Here we are connecting one commutator is there. One commutator is there. This commutator converts DC to AC. DC to AC. Okay, that AC is available in the conductors. So either it is in case of generator or in case of motor, the armature conductors contains AC only. So the answer is option A. The current flowing in the conductors is always AC only. Okay. Coming to the next one. In DC machine, windings are dash. In DC machines, windings are dash. That is full pitch, either of these, short pitch, none of this. Very easy question. Very easy question. Yes, in the DC machine, we always prefer full pitch type of winding. Full pitch type of winding. So what is the advantage of full pitch type of winding? We use generally the full pitch winding to get more EMF. EMF we can get more. More EMF we can get. But the problem is harmonics. Okay, but harmonics are more. Harmonics are more. But here there is no worry about the harmonics in case of DC machines. Why? Because that harmonics will be if we have some harmonics also due to the commutator. Okay, we are getting the DC only. So no need of worry about that. And in case of AC machine like synchronous machine, we use the short pitch. Where there, in case of synchronous machine, harmonics is more dominated. So to reduce the harmonics, okay, we prefer short pitch. Okay, so here DC machine we use to get more EMF we use full pitch type of winding. Answer is option D. Coming to the next one. In normal value of armature resistance of a DC motor is equal to dash ohms. Armature resistance is equal to dash ohms. normal value of armature resistance of a DC motor is equal to dash. Here we have generally field resistance and armature resistances. Okay, if we can consider this armature resistance, if it is a motor, consider the armature resistance RA. RA value must be very low. RA value must be very low resistance. Why? Because it carries more current. If this value is very high, we are getting very high losses. So RA value must be very low. RA value must be very low, and shunt field value must be very high to get low current. Okay, so it must carries the more current to get low drop, less drop at armature. RA must be low. Okay, then only it can carry more current. Okay, so it is low value means it is in the order of 0.1 to 1 ohm. Okay, very less value. So that is nothing but 0.5. Generally, you can take that value as 0.5 ohms. And this resistance, this is the low value of resistance, low resistance. How can measure this one? Low resistance is measured by Kelvin's double bridge. Very important question. Kelvin double bridge. Low resistance measured by Kelvin double bridge. Okay, Kelvin double bridge. Yes, good evening, Saurabh. Okay, how are you? Coming to the next one. The current drawn by a 220 volt DC motor of armature resistance 0.5 ohm and back EMF 200 volt is dash. What is the current drawn? Very easy question. What is the current drawn? $40 amperes. Very good. Very good. Here coming to they are asking about in case of motor. In case of motor, we are giving the supply. Okay, we are giving the terminal voltage. After that, we are getting the back EMF, and also there is a IaRa drop. They are asking about the current, that is Ia we want. From this, Ia is equal to, if you send this EB to outside, terminal voltage minus EB by RA. What is the terminal voltage they have given? 220 volts. And EB 200 volts they have given. By RA is 0.5. In the previous question, there is a question that what is the armature resistance generally. Here in this also they have given armature resistance is generally 0.5 ohms. Okay, so from the problems you can get the data. 20 by 0.5. 20 means 200 by 5. So that is nothing but 40 amperes. Okay, so if we want to carry 40 amperes, the resistance must be low. The resistance is higher. For example, if this resistance is, let us take 50 ohms like that. Okay, then what is the armature current? Very less armature current we have. Okay, so that's why to get the more current flow, we are using generally less value of the resistance. That is 40 amperes. Coming to the next one. The DC shunt motor runs at 500 RPM at 200 volt. A resistance of 4.5 ohm is added in series with the armature for speed control. Armature resistance that is added, the armature resistance value is 0.5 ohms. The current to stall the motor will be dash. The current to stall the motor will be dash. Very easy question. Very easy question. Not getting? Okay, I will give the idea. Current to stall the motor. Stall the motor means stop the motor. Stall the motor means stops. If, for example, if the motor stops, if motor stops, that means the speed is 0. Speed is 0. We know the back EMF, EB is equal to or EB proportional to pi n. As n is 0, EB also 0. So generated EMF is going to be 0. If the generated EMF is 0, then what is the current? We know very well in case of motor, the equation of voltage, terminal voltage is equal to back EMF plus IA RA. Okay, back EMF plus IA RA. So if you want IA, that is here EB is equal to 0 na? 0. So IA is equal to terminal voltage by RA. And here they have connected one series resistance. One series resistance. So you can also add the series resistance. You can also add the series resistance. Here the total resistance is nothing but RA plus RSC. RA plus RSC. Okay. So now IA is equal to this is the total resistance. Terminal voltage. What is the terminal voltage they have given? 220. Armature resistance 0.5. The series resistance 4.5. So total 220 by 5, that is equal to 44 amperes. 44 amperes. So the answer is option A. Okay. Here current to stall the motor is nothing but stop the motor. Stops the motor. Okay. So whenever the motor stops, speed is 0, that is back EMF is 0. So we are getting the terminal voltage is equal to IA into RA plus RSC. Here IA is equal to VT by RA plus RSC. We got the answer as 44 amps. Very good, Saurabh. Coming to the next question. A 220 volt DC machine has an armature resistance of 1 ohm. If the full load current is 20 amperes, the difference in induced voltages when the machine is running as motor and running as generator. Option C, 40 volts. Very good. Yes. Here they are asking about difference in the induced voltages. Difference in the induced voltages is nothing but difference in induced EMF or induced voltages is nothing but 2 into IAR. Okay. So that is 2 into IA they have given 20, RA they have given 1. So that is nothing but 40 volts. 40 volts. Okay, within 5 seconds we can give the answer. Here how we are getting this 2 into IA into RA? Here if the machine is run as generator, what is the EMF equation? EMF is equal to the terminal voltage plus IA RA. In generator, EMF is generated. Okay, that is a terminal voltage plus IARA. If you want terminal voltage, that is E minus IARA. We have to subtract the drop. Then you will get the terminal voltage. If the machine is working as the motor, then what is the formula we have? The terminal voltage is equal to E plus IARA. We are giving the voltage now, so our giving voltage is higher. So from this, E is equal to V minus IARA. Okay, so it is in case of generator. In case of motor, generally you can consider back EMF. The difference in induced voltages. The difference in induced voltage they are asking, that is EG minus EV case V plus IARA minus V minus IARA. Okay, so we get cancelled out. You are getting 2 into IARA. So the difference in induced EMF is nothing but 2 into IARA. So that's why I have taken directly 2 into IARA, that is 40 volts. Okay, so we can easily get the answer within 5 seconds. Very good. Coming to the next question. If a 230 volts DC series motor is connected to a 230 volts AC supply, then what will happen? If this DC series motor is connected to a 230 volts AC supply, then what will happen? Answer is option B. The motor run with less efficiency and more sparking. Very good. The motor will run with less efficiency and also more sparking. Here for this DC series motor, what is the torque? The torque proportional to Ia square. Here square relationship we have. If you apply AC supply, if you give AC supply, current may becomes half of the cycle is positive Ia, half of the cycle is minus Ia also. Okay, so torque proportional to Ia square relation. Due to square relation, torque always proportional to Ia square only. Always positive only. So always positive only means unidirectional torque we will get. Only one directional torque we will get. So if we have one directional torque, the machine rotates. Okay, there is no problem of the rotation. But any problem we can get in case of AC, if you give the AC supply, then due to the frequency we are getting iron losses. Iron losses will be high. Okay, so losses will be high means efficiency is less. And if you give the AC supply, the inductance value is high due to the reactance. As inductance value is the high, then commutation is poor. Due to this inductance, we are getting reactance voltage increases. Due to that, we are getting sparking at the brushes. Sparking happens. Okay, so we are getting the excess amount of the sparking, less efficiency, but machine will be runs. So the motor run with less efficiency and more sparking. Okay, the motor will run with less efficiency and more sparking. Coming to the next one. What will happen if the supply terminals of DC shunt motor are interchanged? If we interchange the supply terminals of DC shunt motor, what will happen? Very, very important question. Very good. will run in same direction. Very good. Motor will run its normal speed in the same direction as it was running previously. The answer is option B. Here they are asking about the shunt motor. Let us take a shunt motor. I don't want to give a very big explanation and all those. I want to do in a simple manner. Okay, we don't want any detail. We have to understand in a simple manner. We know the rotation. They are asking, the options are all belongs to rotation. Rotation means when the motor rotates, whenever it have the torque. Torque is nothing but force in a angular direction. So if we have the torque, the motor will be rotates. So let us take a torque equation. Torque proportional to pi into Ia. Am I correct? Torque is always depends upon pi and Ia. For example, we have the connections like positive and negative. Okay, the connections are like positive and negative. So positive is connected means generally we can take flux as positive and Ia as also in the same direction, Ia also as positive. Okay, so both are positive, positive into positive, so torque is also positive, so we can get one directional torque. One directional torque. That is, you can say unidirectional torque. Generally we can call it as unidirectional torque. If you reverse the supply, that means let us take minus and plus case. Then what about the flux? Flux will be in reverse direction. Okay, that is a negative positive means south north will be reverse. South north will be reverse means reversal direction will get the flux. And if you reverse the supply, Ia also will becomes negative. That is, direction is changes. Okay, so now what will be the torque? Minus pi minus Ia. So torque proportional to again pi into Ia only. So again you are getting unidirectional torque. Again you are getting unidirectional torque. So we are getting the same directional torque means same direction. It will have same direction. Okay, so the answer is option B. But when we can get reversal of direction, if you want to get reversal of direction, either you have to change your flux or your armature current. If you change your flux, then also torque will be reversed. If you change your armature current also, then you can get the change in the torque. Okay, those two are those. If you reverse any of those, either flux, either armature current, that means either field terminals or armature terminals. If you reverse either field terminals or armature terminals. Okay, motor run in reverse direction. Okay, but not both students, either field or armature only, but not both. And coming to the next one, the highest speed attainable by DC shunt motor is test. The highest speed attainable by DC shunt motor is test. Very easy question again. Very good. That is nothing but equal to no load speed. Coming to characteristics of this shunt motor, the speed with the load characteristics. Okay, here what is happening? This speed is going at no load. We have very high amount of the speed. The speed will be very higher. And as the load increases, we are getting the drop. Drop will be increases. Due to that, the speed will be falls. Due to drop, we are getting the speed will be drops. We know very well back EMF directly proportional to pi into Ia. Okay, sorry, pi into N. Pi into N. So here N proportional to EB by pi. EB by pi. EB is nothing but V minus Ia Ra. V minus IRA by pi. So if the load current increases, Ia also increases. So this drop is increases. If this drop negative part is increases, the speed will be false now. The speed will be false. This total part is going to be decreases. The speed will be false a little bit. So highest speed is nothing but which is obtained at no load only. As the load increases, speed will be going to be decreases a little bit. So highest attainable speed is nothing but equal to no load speed. Very good, Saurabh. And coming to the next one. As the load is increased, the speed of DC shunt motor is dashed. The speed of shunt motor is dashed. Reduced slightly. Very good. Actually, just now we have discussed in case of no load, we have the speed like this. In case of as load increases, the speed will be decreases due to IARA drop. Okay, this is the speed in case of full load. So it is slightly reduces. Okay, if this option is not there, we can take almost constant. We can take the option almost constant. If slightly reduces is there, then we have to do the answer as option A. Coming to the next one. In DC shunt motor, if the terminal voltage is reduced to off and the torque remains the same, when it will happen? When it will be happen? Answer is option C. You have given. Let us check what they have given. Torque. Torque is same. Torque proportional to pi into Ia. It must be same. Okay. And what they have given, terminal voltage is reduced to off. If this terminal voltage is going to be off, then what will happen? Terminal voltage is going to be off, then what will happen? If the terminal voltage is going to be reduced to off, then what about the flux produced? Flux produced will becomes off. Okay, if the flux produced will becomes off, to get same amount of the torque, it draws double the current. Motor draws double the armature current. Then what will happen? Torque proportional to pi is pi by 2. Ia is 2 into Ia. Then this 2 get cancelled out. Torque proportional to pi into Ia only. Okay. So we are getting the constant torque. That is the torque remains same. So what is the option is correct here? Flux will be off. And armature current is going to be double. and it becomes double. So the answer is option C. So the answer is option C. Okay. So the answer is option C. And coming to the next one, the direction of rotation of DC shunt motor can be reversed by interchanging the dash. Can be reversed by interchanging the dash. Just now we have discussed about this question. Just now we have discussed about this question. Very good, option B. Just now. Yes, here. Torque proportional to pi into Ia. Here, if the supply is like positive or negative, then we are getting both are, let us take a positive. If you reverse the supply, both becomes negative, then torque will becomes negative, that means again positive. So you are getting same unidirection. So if you change the supply, then you may not reverse it. But if you reverse any of the either field terminals or either armature terminals, then the motor will get reversal direction. I have already explained that one. Torque proportional to pi into Ia. So if you reverse field terminals, then pi will be reversed because of north and south will be reversed. Okay, then what will happen? Torque proportional to torque proportional to minus pi into Ia. That means you are getting negative torque, that is nothing but reversal in the torque. Motor direction reverses. Okay, in the same case, let us take if you reverse armature terminals, then current will becomes reverse. So torque proportional to pi is same, armature current only reverse. So you are getting reversal direction. So if you change either armature terminals or either field terminals, then you will get the reversal in the direction. But if you change the supply terminals or if you change both armature and also field terminals, then we have same direction. Okay, so either field or armature terminals. If you change either field or armature terminals, then only we can get reversal in the direction. Okay. And students, the next class in the same YouTube channel. Okay, the timings are 8 p.m. to 8:45 p.m. Okay, so don't forget to attend for the next session. We will continue the remaining questions in the DC motor topic. Okay, and if you want to get my other electrical sessions, just visit Unacademy JE and AE exams channel. Unacademy JE and AE exams YouTube channel. In that you will get so many sessions. Okay, and students, if you want to get complete access of all my theoretical courses and also practice sessions, get subscription by using the referral code Suneel Sir SSC. Okay, and you will also get the maximum discount for that. And I want to show you what are the courses you can get access in Unacademy Plus under SSC exams category. The theoretical courses: circuits, machines, power systems, measurements, and also basic electronics. Practice courses: circuits, machines, power systems, measurements, basic electronics, utilization, and also physics and chemistry. Okay, if any non-technical student can also get physics and chemistry. And remaining educators, that is remaining subjects by other educators, utilization, estimation costing for JE examinations, control systems and power electronics for AE examinations. Okay, use this referral code Suneel Sir SSC to get instant discount. Select your goal as SSC examinations and click on get subscription. Select the number of months. Here apply the referral code Suneel Sir SSC. After that, click on proceed to payment. After payment, you will get access to all the crash courses. You not only get my classes, you will also get all the crash educator classes. Okay. Okay, students, will meet in the next class, that is today 8 p.m. session. Thank you so much for watching, and also please share the information to all your friends of these classes. Okay.